In this video, we are going to talk briefly about soil mixes and the qualities that you'd like to have in a soil mix, whether you make it yourself or you purchase in a soil mix. And then we're also going to talk briefly about some of the different container options that we typically use in an operation of our scale, but also what you might have access to use on a home scale that could work depending on the crops that you're growing. So first of all, with soils and soil mixes in a greenhouse setting, we're looking for a few key things in a mix. We need drainage and aeration and moisture retention. And those three elements go hand in hand, though they maybe sound a little bit contradictory simultaneously. We need to be able to retain enough moisture to meet the needs of the seed and seedling where it's at in its life cycle, but we also need to drain off excess moisture, and simultaneously, once that drainage has taken place, we want to have good aeration in the root zone, in the pore space of the mix, just as you have pore space in your soil structure in the ground, and that's something you're really trying to foster through your cultivation practices and compost and cover cropping and such. We are also trying to make sure that in our constructed soil mixes that there is good pore space, because the oxygen infused down into the soil is very, very important for healthy seed and seedling development. So how do we go about getting drainage and aeration and moisture retention? What are some of the ingredients that bring those things to us? For things like drainage, I'm going to be thinking about sand, perlite, vermiculite, any sort of coarser composted, partially composted materials. For things like for aeration, I'm going to be thinking about basically those same ingredients: perlite, vermiculite, sand, other coarse, more open things. When I'm thinking about moisture retention, that's going to come through ingredients such as vermiculite, which is tremendously successful at retaining moisture, but then also things like cocoa peat and true peat moss. Those provide some drainage and aeration, but they also provide excellent moisture retention. And then things like compost might be another resource for you for moisture retention. And then I mentioned compost because compost is also an ingredient that many soil mixes, whether purchased or made at home, would be one of your primary sources of fertility. That could be a plant or an animal or manure-based compost, but that is one way that we're going to think about getting fertility to our crops. Another way is to think about byproducts of some of the other industries that are out there. So for example, you will commonly see blood and bone meal, alfalfa meal, feather meal. These are all byproducts of industry and of food processing and such that are commonly found as fertilizers in organic systems, and when readily available, meaning they will be available in short order, they can also be in soil mixes. There are other things like seabird guano and such that might be a good resource. A lot of people will use kelp meal as well for a micronutrient resource, but we need to think about provisioning for fertility in one way, shape, or form. And then the last really central thing that I'm going to think about is I want to have a pathogen-free environment. I don't want to be introducing anything in my mix that is the source of pathogens, be that weed seed or fungi and bacteria that could prey upon my seedlings. So pathogen-free environment is something that we're going to try to create and then maintain through our cultural practices, how we manage water and air circulation. And we're, in many cases, even going to be thinking about trying to promote a positive, beneficial bacteria and fungi environment through introduction of things like a trichoderma fungus, which is a beneficial fungus that preys on pathogenic fungi that in some cases people will blend into their soil mixes as well. So soil's foundational: drainage, aeration, retention, fertility, pathogen-free environment are things we're thinking about. And then when we think about containers, on our scale here, most of what we grow in some sort of what we call cell or plug-like container. And they come in a variety of sizes and dimensions. The three in this stack are what are referred to as 1326s, 13 inches here, 26 inches this way. The two in this stack are what are referred to as 1020s, 10 inches by 20 inches. Both can work in a production setting. These are a little bit more expensive, but have a very, very long lifespan. The hard plastic ones do. The Seedling, the styrofoam one here, we like because we have these really nice large cells, but we don't like them because, like many of the ingredients that go in our soil mixes, polystyrene is a very non-sustainable and kind of environmentally costly input and tool that's used in farming systems. So we really try to minimize our use of the styrofoam ones. We like these lighter weight plastic trays because they are fairly inexpensive. They come in many different cell sizes. The one thing to just be aware of with them is that they have kind of a finite lifespan because they're kind of flexible. They can bend and break and crack over time. On a home scale, you might be thinking about some sort of container like this, kind of your standard cell pack or 6-pack. This one here is what we would call a jumbo 6-pack, a slightly larger and deeper cell. And then this is just a 3-inch pot. Regardless of the scale that you're working on, we want to think about cell size that is suited to the crop that we're growing. I don't want to put a really giant plant like a summer squash into a teeny little cell like this because there's just not going to be enough root run for it. But maybe I'd be just fine in a larger cell like this 2-inch size cell here. Similarly, I don't want to put an onion or scallions in a giant cell like that because I have a fairly small and finite root system and I don't need a lot of root run for them. So maybe I'm going to be just fine in a tray like this, which has got 512 cells, or maybe a tray like this with only 200 cells. Ultimately, whether you're working on the home scale or on a kind of farm and production scale, trying to balance the container type and cell size with the root nature of your crop is critical. And then also with the amount of space you have available. If I have a very small greenhouse, but I'm trying to grow a lot of seedlings for a larger area, then I'm going to favor smaller seedlings because I'll be able to cram more seedlings into a larger, into that small space. If I have lots of greenhouse space, or I'm not as certain that I'm going to be able to get things out on time, then maybe I'm going to favor larger cells because I can grow a bigger, more robust seedling, which has a little bit more window of opportunity before planting it out, before it starts to stress out in the container because it's run out of resources or the root system has started to become crowded in the container. So really, we're going to think about informing our choices based on the nature of the crop and the scope of resources that we have available, and then trying to make good decisions that meet plants' needs and fit within the resource base that I have to work with. So hopefully that gives you a little bit of insight into both soils and containers. And you are welcome to, and there's ample resources online that we'll provide through Canvas of some additional videos that go into greater depth on these subjects. Thank you very much.